Alright, so for my Knime challenge, I looked into a census data set relating income to a bunch of different predictor variables. It was a pre-made data set that was available for machine learning. It's 1994 census data, so it's a little old, but it had a pre-coded target variable, which was income greater or less than $50,000. So I just went ahead and used it for ease. So I read that in and I added column names because the file didn't have column names in the source. And I dropped some extraneous columns and I recoded the target variable just for ease of looking at results. I found it easier just to see true or false with a column heading instead of this character string, but it's really a personal preference. And I finally, the last step in pre-processing was I dropped any row that had a missing value, which ended up being about basically 2,400 cases, 7.3% of the original data set, which is, a substantial amount, but not huge, and I really had no choice, so I accepted that. So the first thing that I wanted to do was get to know the data. So the first thing that I did was a statistics node, which let me look at both numeric and nominal attributes in the data set. So for numeric attributes, this makes a table with all of the standard summary statistics, min, max, mean, standard deviation, etc., as well as a histogram of the variables themselves. So you can see most people work 40 hours a week. Most people don't have any capital gains or losses in a year, and that's generally the age distribution in the US. If you looked at one from more recent, it might be shifted a bit right because the baby boomer generation has gotten older since 1994, but generally that is the pattern in Western or developed economies. And like I said, you can also look at nominal attributes. So this makes a histogram of all of the values in each nominal attribute. So we've got employment type, private, different levels of government, etc., educational attainment, marital status, occupation, relationship status, which I think is an interaction between marital status and sex, because you've got married, husband, wife. I think that's a combination. Race, sex, and the outcome, the target variable. I also had weights. The data set came with weights. You might have seen that here. It doesn't really come into play in most of these classifiers. They don't take weights into effect as far as I know or could figure out. The one that might is logistic regression. You can use weights in a regression, but none of these are computing aggregate statistics, so they're not going to take in the weight. But I did want to just figure out how I might use them if I were going to. So I calculated the weighted mean of age in the data set by multiplying the age and weight columns together and then dividing the sum of that by the sum of the weights, which gave me 37.878 as the weighted mean age in the data set, which is different from the unweighted mean of 38.438. So it was just interesting, and I liked figuring out how to do that. And then I also, moving towards classifiers, I did something sort of like attribute selection, though I didn't actually limit, drop any attributes based on it, a correlation matrix, just to see, the relationships between the variables, specifically between each variable and the target. So as we can see, these variables right here have the strongest correlation with the target, and those are education and occupation, and then there's relationship, marital status variables as well. So we can probably expect those to be used early on in any classifier that we make. So the first one that I made was just one-time 90-10 random sampling partition that I got a training set from, and used a random forest learner using an information gain evaluator, and that gave me fairly interesting trees. Let's see if we can expand it really quick. Not very simple, but not overly complicated either, and most of this makes sense if you follow it through. It's like we expected, splitting on relationship, and then splitting on some of the other demographics as well. That, however, did not end up being a great model. Ultimately, we got 80, call it 85% accuracy, so 15% error, which is not terrible, but it's not great, and that is test accuracy. The training accuracy was about the same. So I wanted to see if I could improve that with some of these other classifiers, but first I wanted to just check the stability of this random forest output. Check and see if I got the same accuracy splitting the data set, doing multiple validations, which is exactly what's going on here. This basically creates a cross-validation loop, so everything in here is done however many times you specify, which I specify 10 validations. So it's doing the exact same random forest model, and the error is pretty much the same, 13 to 15% error, which is pretty much exactly what we got here. So that meant the random forest models are stable, they're just not really highly accurate. So I wanted to see if I could come up with a different classifier that did a better job. So the first one that I looked at was logistic regression. I ran into a couple problems. The main one is I could never get the regression to converge, to actually to settle on parameter values or coefficients, which was a problem. And I increased the number of epochs at Knime's recommendation, and never was able to get it to converge. So none of this output is probably perfect. Again, I was cross-validating, and Knime also told me that it wanted any numerical values going into this logistic regression to be normalized, so I added this in. This wasn't here at first. And even after normalizing those, it still asked me if they had all been normalized, so I wasn't sure exactly what's going on there. And again, error actually got worse on average. So that was not an improvement. The next thing that I tried to do was an SVM, but I didn't think about it until I started running it or trying to run it. It can only use the numeric attributes, so 4 of my 12 predictors, and it also, I let it run for like 10 to 15 minutes and it never resolved, and so I canceled it and I changed a couple things and I tried it again and it didn't resolve after 10 to 15 minutes again, so I never actually got this to complete. But it would have only been on a handful of attributes in the dataset to begin with, and I would have excluded a lot of the most interesting ones like education, relationship, etc., that were the most highly correlated. So it wouldn't have probably been that useful anyways. So the last thing that I did was basically go back to where it all started with a Weka J48, just because we're very familiar with those, and I had again did 10 validations, and the output from that was pretty decent. It was a pretty good tree. If I can get it to, there we go. So splitting on capital gain, if you have a lot of capital gain, you probably are high income. If you don't have that, if you didn't have much capital gains, then if you are married, then it did a bunch of other stuff. But if you are pretty much anything other than married, so divorced, never married, separated, widowed, you're probably lower income, and in a couple specific marriage situations, you're probably lower income as well, according to the model. If your spouse is in the armed forces, or if you're a spouse of someone in the armed forces, probably lower income. And if there's some sort of situation going on in the marriage as well, income is predicted to be lower. Then it splits a couple more times, uses these different occupation categories, etc. If you are lower education, if you have less education, income is predicted to be lower as well. So that all checked out, and we can really quickly look at the tree format, Weka's tree output. And we see that again, just easier to look at graphically, splitting on capital gains. Marriage, higher education, more likely to be higher income, low education, more likely to be lower income, and then splitting on all those occupations. So yeah, that is how I tried to classify people's income using that 1994 census data set. If I were going to try and really, and the error rates were even worse again. So if I were going to try and find a classifier that did a better job at this, honestly, I would probably just dump to a CSV right here at this point and import it into Weka, and then use Weka's interface to try and isolate a better classifier, just because I've personally found it easier and quicker to try out a bunch of different parameterizations and different classifier types in Weka, because it's just a couple clicks, whereas here you have to keep creating these flows, and changing the parameters is still not that hard, but making all of these flows takes more time than just clicking in Weka. But if I were going to do anything with that, with the model produced by whatever classifier I found got me the lowest error, I would definitely come back into Knime, set up a flow that made whatever classifier I found in Weka, and then use the output in Knime, because I really like Knime's interface, and I think it would be really useful. So yeah, that's my Knime challenge.